Hello everyone, I am Dr. Sunil Shingade and presenting the research on the designing of eco-safe pressure cooker. Eco means energy saving, means fuel saving, means ultimately money saving. The second is time efficient, means save time, save money. And the third one is the reduce manpower cost, means less manpower consumption, means ultimately money saving. Therefore, it is called as eco. It is safe at higher pressure on large scale cooking. Therefore, it is called as eco-safe pressure cooker. Cooking sector is the most energy consuming sector in the developing countries, and therefore 31% of the energy is going to utilize in the cooking sector. Out of that, 30% comes from gas, kerosene, coal, and remaining 69% comes from firewood and agricultural waste. But gas, kerosene, coal or fuel oil are steadily depleting fuel sources. Agricultural waste or firewood are non-commercial fuels. Therefore, they are not economically viable and environmentally also not beneficial. There are two types of cooking methodologies. The open pan cooking system, which is placed on the flame directly, and the second one is the closed steaming chamber. Open pan cooking system consists of pot which contains the mixture of food grains and water, and it open to the atmosphere, and that pot placed on the flame directly. The quantity of water going to absorb by rice during cooking is of 2.5 times more. Means 1 kg of rice absorbs 2.5 kg of water, and 1 kg dal absorbs 3 kg of water. But in open pan cooking system, we are taking this ratio 1:5. Therefore, we are using excess amount of water, and that excess amount of water going to vaporize, and heat loss is taking place in the form of both sensible heat content and latent heat content. Therefore, open pan cooking system is not fuel efficient or energy efficient. The second art of cooking is direct steam cooker. Direct steam cooker consists of multiple vessels which are placed one upon another. The bottommost vessel contains water, and upper vessels are perforated from the bottom and contains the food grains. The bottommost vessel placed on the flame directly, and therefore the water in that vessel gets boiled and steam gets generated. That steam travels upward and passes through the perforated bottom, and therefore steaming of the food grains which are placed inside the upper vessels takes place and the cooking occurs. But the technical problem associated with this is that we can increase the temperature maximum up to 100 degrees Celsius because it is open to the atmosphere. Because the boiling point of water at sea level is of 100 degrees Celsius. And the second is there are chances of getting loss of steam to the surrounding, and therefore heat is going to loss in the form of sensible as well as latent heat content. Therefore, it is also not fuel efficient. Another method is indirect steam cooker. Indirect steam cooker are widely used. This consists of multiple vessels placed one upon another. These vessels contain the mixture of food grains and water and enclosed by a steaming chamber. Steaming chamber consists of the basal receptacle which contains water and it is placed on the flame directly. These cookers can operate at atmospheric pressure and can operate also elevated pressure, means at high pressure. When the basal receptacle is placed on the flame, then water gets boiled and steam gets generated, and that steam gets generated inside the steaming chamber and get condensed on the outer wall surface of the vessels and transfers latent heat to the vessel contents, and therefore temperature of the vessel contents increases and cooking proceeds. But the problem associated with the indirect steam cookers which are operating on at high atmospheric pressure are as follow. There are chances of escaping steam to the surrounding, and therefore heat loss takes place. This is the first problem. Therefore, heat energy efficiency goes down. And the second one is the uniform cooking cannot be carried on the large scale because there are chances of getting formation of temperature dead zones inside the cooking vessels, and therefore uniform cooking cannot be carried out. If we consider the case of pressure cookers, these are also indirect type of steam cookers, but their size is limited to 10 to 20 liters because of the safety limits. The environmental aspects of the cooking operations are as follows. In developed countries, electricity is used as the fuel for carrying out the cooking. Electricity is considered as the clean fuel, but combustion of coal for formation of electricity produces carbon dioxide, carbon monoxide, and this carbon dioxide absorbs the solar energy, and therefore ambient temperature increases. Our ambient temperature increases or ambient atmosphere gets warm because carbon dioxide is the greenhouse gas. In developing countries, liquefied petroleum gas or pressurized natural gas are used as a fuel for carrying out the cooking. But combustion of these gases in confined spaces of the kitchens produces carbon dioxide which affects the health. The effect of carbon dioxides on human health are as follows. Carbon dioxide causes difficulties in breathing, it increases the heart rate, it increases the blood pressure, it causes the feeling of tiredness. Therefore, it is need of our through all aspects to apply energy conservative strategies to the cooking practices so that we can carry out the cooking with less fuel consumption so that carbon dioxide formation will get reduced, and it is environmentally beneficial, and it is good for maintaining healthy atmosphere. Cooking is the basic need of human life. It is consumes 30% of the total energy of the world. Cooking is a physico-chemical process, and therefore it is need of our to apply energy conservative strategies to the cooking process. We have done the experiment of cooking with indirect steam cooker operating at atmospheric pressure, and from this experiment we have observed the novel phenomena of heat transfer and fluid mechanics occurring inside the cooking vessel. And on the basis of that, we have designed the energy and time efficient pressure cooker. Therefore, theme of our project is save fuel, save money, save time, save money, less manpower consumption, save money, less fuel consumption. It is environmentally beneficial and good for maintaining healthy atmosphere. According to the novel phenomena, it is observed that once the heat is supplied to the indirect steam cooker, the temperature inside the vessels increases. And if the temperature of the water inside the cooking vessel rises up to 95 degrees Celsius or more than 95 degrees Celsius, then there is no need of further heat supply, because sensible heat content inside the water is sufficient for carrying out the cooking to the completion. Therefore, there is no need to maintain the heat supply till the cooking process gets complete. This phenomena is observed, and the second thing is that when we stop the heating, then low temperature water having higher density resides at the bottom side of the vessel and or the lower side of the vessel, and the high temperature water having low density resides at upper side. Therefore, there is a vertical temperature gradient gets developed inside the cooking vessel. And if the temperature of the water residing in the vicinity of or inside the whites of food grains, inside the bed of food grains equal to the temperature required for cooking, then cooking gets initiated, and therefore water gets absorbed inside the food grains. The place of that absorbed water is going to take place by the upper water. Therefore, upper water get trickled down. This upper water is at comparatively higher temperature. Therefore, the temperature inside the bed increases continuously. It clearly indicates that fluid mechanics and heat transfer is going to change even after terminating the fuel supply. Means it clearly indicates that even after terminating the fuel supply, cooking gets proceed or cooking gets continue. On the basis of these novel phenomena, we have developed the cooker which is applicable from household kitchens to the commercial kitchens also, commercial scale also, which saves 70 to 80% of fuel as compared to the open pan cooking system, and it accelerates the cooking and it cooks at the rate faster than the pressure cooker. This is the schematic of the experimental setup which we have used to study that novel phenomena. It consists of multiple vessels which are placed one upon another. These vessels contains the mixture of food grains and water, and these vessels are enclosed by a steaming chamber. The steaming chamber, having the bottom portion which we call as the base basal receptacle, contains water and it is pressed on the flame directly. Therefore, water inside the base of the basal receptacle gets boiled, generates steam. That steam travels upward, get condensed on the outer wall of the vessels and transfers latent heat. Therefore, temperature inside the vessel, temperature of the vessel contents increases and cooking gets proceeded. Every vessel contains 3 kg of rice and 7.5 kg of water, means 2.5 times more. And temperature sensors are located inside each vessel at 25 mm and 50 mm from the base of the vessels. The liquefied petroleum gas, that is LPG gas, flow rate was maintained at 16 gram per minute. And from this experiment, it is observed that temperature rises even after terminating the fuel supply, and once the temperature of water rises equal to or above 95 degrees Celsius, then there is no need of further heat supply, because the sensible heat of contained inside the water at the temperature of 95 degrees Celsius or above is sufficient for carrying out the cooking operation or cooking process to the completion. This is the schematic view of normal cooking vessel. It consists of 2 portions. Portion 1 contains free water, while the portion 2 contains the bed of food grains along with water inside the void of that bed. The heat transfer to the portion 1 is completely controlled by convection, but the heat transfer in portion 2 is partly controlled by conduction and partly controlled by convection due to the presence of food grains. The area available of portion 1 is entirely available for heat transfer, but in portion 2 it is partially available because of presence of food grains. Therefore, temperature of water inside the bed, the temperature of the water inside the portion 1 increases at the faster rate than that of the portion 2. Therefore, temperature of the water residing in the whites of the bed of the food grains rises slowly. Therefore, high temperature water having lower density resides upper side, and low temperature water having higher density resides bottom side or lower side. And once the temperature of water residing inside the base of food grains, inside the bed of food grains, reaches the minimum cooking temperature, then water gets absorbed inside the food grains, and the place of that absorbed water is going to take place by the upper level water. Therefore, upper water gets trickled down, which is at comparatively higher temperature. Therefore, temperature inside the bed increases continuously even after terminating the fuel supply. On the basis of that, all these phenomena which are observed, we have developed the hooking the pressure cooker which is applicable from household kitchen to the commercial scale. The first design aspect of our cooker is to heat up the water trapped inside the whites of the bed as in a short time as possible. This is the schematic view of the newly designed cooking vessel. It consists of three portions: portion A, portion B, portion C. The base of the cooking vessel is of dish type and it is covered from the inside by a perforated plate or wire mesh. The water is filled below the perforated plate, which is called as portion A. The bed of food grains along with water is placed above the perforated plate and the free water is available in portion C above the bed of food grains. The water present in portion A and portion C is free water and the heat transfer to these two portions is completely controlled by convection. But the case of portion B is different. The heat transfer in portion B is partly controlled by conduction and partly controlled by convection due to the presence of food grains. The entire surface area of portion A and portion C is going to utilize for heat transfer, but in portion B it is partially going to use due to the presence of food grains. Therefore, temperature of water present in portion A and C increases at higher rate than that of the portion B. As the temperature of water in portion C increases, then its density reduces. As the temperature of water in portion A increases at the faster rate or gets heated up earlier, then its density reduces and therefore convective currents get developed. These convective currents rises up and enters inside the bed, and at the same time relatively cold water of the bed flows downward and takes the place of uplifted water. Therefore, water content of the bed gets heated up as in a short time as possible due to the convective currents which are formed inside the portion A. The base of the vessel is of dish type. It is designed in the dish type because to increase the heat transfer area. Because the dish type base is having the larger surface area than the flat surface, and therefore more and more steam gets condensed at the base of the vessel, and therefore temperature of the water inside the portion A gets heated up and gets develop the convective currents, and these currents get passed inside the bed of flow grains. Therefore, the water inside the bed of flow grains gets heated up as in a short time as possible. The base of the vessel is of this type because the water hold up below the perforated plate inside the portion A increases, and therefore temperature gradient can be maintained for a longer time, and therefore more and more steam gets condensed at the base of the vessel, and therefore convective currents gets developed, and these convective currents gets passed inside the bed of flow grains, and the water inside the bed of flow grains gets heated up as in a short time as possible. The second aspect of the designing is to increase the overall rate of steam condensation, and it can be done by increasing the area of heat transfer. Therefore, the vessels of smaller sizes are designed rather than of one bigger size. If the vessels are of smaller sizes, then surface area increases, and therefore heat transfer takes place effectively and steam gets condensed at higher rate. These vessels are placed in a vessel stack in a triangular or a square pitch, and these vessel stacks are placed one upon another by maintaining the clearance between each other so that steam gets circulate through an angle of 360 degree, and therefore heat transfer coefficient increases and steam gets condensed at the higher rate, and therefore temperature of the vessel content increases as in a short time as possible. The third aspect is also to increase the rate of steam condensation by increasing the temperature gradient between the steam inside the steaming chamber and the vessel content. If the temperature gradient between the steam and the vessel content increases, then the steam gets condensed at higher rate, and it can be done by generating the steam of having high vapor pressure and high temperature. Therefore, the cooking is carried out under pressure, high pressure, up to 120 degrees Celsius, means up to 2 bar of vapor pressure, because at 120 degrees Celsius the equilibrium vapor pressure of water is of 2 bar. The double wall jacket is used to balance this high pressure. This double wall jacket consists of 2 walls, inner wall and outer wall, and between them hollow space is present. That hollow space is filled by an air which is having the pressure in between the pressure inside the cooker and the pressure of the open atmosphere. Therefore, the pressure gets balanced and it prevents the cooker from getting burst if we use it on a large scale also. These are the photographs of the cooker which I have fabricated. This is the vessel stack having the triangular pitch. These vessels are placed on these stacks, and this is the wire mesh which is placed inside the each vessel above the base of each vessel, above the inside base of the each vessel. And this is the bubble plate, and vertical stand is mounted at the center, and it is placed inside the bustle receptacle. This is the schematic view of the invented novel pressure cooker. It consists of multiple stacks of the cooking vessels which are placed one upon another, and clearance is maintained between the stacks. And these vessels contain mixture of food grains and water. Each vessel is covered from the inside side, the base of each vessel covered by a perforated plate or wire mesh from the inside. Means inside base of each vessel is covered by the perforated plate. And this assembly is enclosed by the steaming chamber. Steaming chamber consists of two parts: the hollow air jacket on the upper side and bustle receptacle on the lower side. In the base of the bustle receptacle, water is taken and this is placed on the flame directly. When it boils, when the water gets boiled in the base of bustle receptacle, then steam gets generated. This steam travels upward and transfers latent heat to the vessel contents, and therefore temperature of the vessel content increases and cooking gets proceeded. This is the inside view of large scale novel pressure cooker, which consists of the vessel stacks which are placed one upon another. These are held together by the central stand. Each vessel stack consists of 3 vessels which are placed in a triangular pitch, and these vessel stacks are placed on a bubble plate which is placed inside the vessel receptacle. This is the outer view of the overall assembly of large scale novel pressure cooker which we have fabricated. The experiment is carried with our pressure cooker, designed novel pressure cooker. It consists of 9 vessels. Each vessel consists of 1 kg of rice and 2.5 kg of water. Therefore, total rice is 9 kg and total water inside the vessels is of 22.5 kg. And gas is supplied at the flow rate of 16 gram per minute for 25 minutes continuously, and then it is terminated and the system is allowed not to disturb for 30 minutes, means it is holding time. The total gas consumed is 400 gram, and after that the entire rice is cooked and the uniform cooking is obtained. But the same quantity of rice is taken into the large open pan and 5 times more water, that is 45 kg of water is added, and heating is supplied for 75 minutes at the same flow rate, means at the 16 gram per minute, and therefore total gas consumed was 1200 gram. But it is observed that there are some portions where temperature dead zones are formed. That portion is partially cooked or not completely cooked, means uniform cooking is not obtained. Therefore, our designed novel pressure cooker is efficient for carrying out uniform cooking with the fuel saving of 70 to 80% as compared to the open pan cooking system. If we consider the environmental aspects, due to the combustion of the fuels in the cooking sector, carbon dioxide gets formed and it causes adverse effects on the human health. And these effects are dependent upon the concentration of CO2 in the confined spaces, and these are tabulated in this table. These are the household cooking sector concentration of carbon monoxide, carbon dioxide, sulfur dioxide, nitrogen oxide and nitrogen dioxide. These are the gases or pollutants going to release from the combustion of LPG gas in the household kitchen, and the resultant concentration is tabulated as in this table, and this is taken from the reference, and on the basis of this reference we have estimated the concentration of these pollutants going to develop if we use or if we carried the large scale cooking on hospitality sector or in commercial kitchen. And from this study it is observed that the invented cooker is capable for maintaining the concentration of these pollutants much below than the open pan cooking system. Therefore, the invented cooker is environmentally beneficial and it is good for maintaining healthy atmosphere inside the commercial kitchens also. The significance of the large scale normal pressure cooker as well. It is useful on hospitality sector. It is useful on household purpose also. If I consider the case of the hospitality sector, there are 9 to 12 different food items can be cooked simultaneously at the same time with 70 to 80 or 60 to 70% of the fuel saving as compared to the open pan cooking system. Therefore, money can be saved ultimately. The cooking is carried out in minimum time, therefore it is time efficient, therefore save time, save money. The number of items can be cooked simultaneously, therefore less manpower consumption is there and it ultimately saves money. As far as environmental aspects are considered, the combustion of LPG is less and therefore less amount of carbon dioxide get formed, and therefore global warming effect can be reduced. And one more thing is that in this cooker there is no need to carry out the pre-soaking of the food grains or the washing of the food grains separately or before carrying out the cooking, because it takes place automatically while the heating operation or heating process is in progress. Thank you. The conclusion summary of the energy and time efficient cooker is as follows. The novel phenomena of heat transfer and fluid mechanics occurring inside the cooking vessel is observed, and it is as follows. If the heat is provided to the indirect steam cooker, then temperature of the vessel content increases, and once the temperature of the vessel content or the water of the vessel content increases up to 95 degrees Celsius or above the 95 degrees Celsius, then there is no need of further heat supply, because the sensible heat content inside the water of the vessel content is sufficient for carrying out the cooking process to the completion. And the second thing, once how it is proved the cooking gets proceed even after terminating the fuel supply. This can be concluded from the novel phenomena of heat transfer and fluid mechanics occurring inside the cooking vessel, which is main elaborated as follows. Once we stop the heating process, heat supply, then the temperature gradient inside the cooking vessel, vertical temperature gradient inside the cooking vessel gets developed, because low temperature water of having higher density resides lower side, and low temperature water of having higher density resides lower side, and high temperature water having low density resides upper side. Therefore, low temperature water is at the lower side, high temperature water is at the upper side because of relatively low density. And once the temperature of water inside the bed of food grains reaches the minimum cooking temperature, then water gets absorbed inside the bed of food grains, and the place of that absorbed water is going to take place by the upper water. Therefore, upper water gets trickled down, which is comparatively at higher temperature. Therefore, temperature inside the bed of food grains increases continuously even after terminating the fuel supply. And this is the magical phenomena clearly indicates that the fluid mechanics and heat transfer inside the cooking vessel get changes even after terminating the fuel supply. Means the cooking gets proceed even after terminating the fuel supply. And on the basis of that, we have designed the cooking novel pressure cooker, in which each and every aspect of heat transfer is taken into consideration to increase the heat transfer rate to the vessel content, and therefore temperature of the vessel content can be increased in a short period of time, and uniform cooking can also be carried out. Thank you.